Okay guys, today we're in section 9.2. We're finding the area of circles today. This really goes hand in hand with 9.1. 9.1 we find circumference, which is like perimeter. 9.2 we're finding area. All right, this is by far the easiest, let me back up. The shortest, possibly the easiest. I don't like using that word, but it's a pretty short lesson today. Covering areas of circles. Of course, to find the area of a circle, something would be really important. The formula. Now, what you notice about the area of a circle, the formula. How many formulas do you have, guys?
50.
How many formulas do you have?
One.
And that formula calls for which value? R. R stands for? Radius. So if they give you diameter, there is no option to plug in the diameter value. You must plug in the radius value. So that's where we see some mistakes happening for area. They'll be given diameter and plug in the diameter value. Don't do that. Okay, so let's look at example 1. In example 1, it says find the area of the circle. Use either the decimal or the fraction value for pi. Does anybody remember, how do I know when to use the fraction? Anybody remember? Hadley?
Yeah, whenever it's a multiple of 7.
Thank you. Okay, so yes, whenever it's a multiple of 7, that's when I can use the fraction, and it just gives me a cleaner answer. Doesn't necessarily mean the fraction will be right and the decimal will be wrong. Just gives a bit of a cleaner answer. All right, so it says find the area, so I'm going to use my formula. A equals pi r squared. All right, so now I have to decide which value do I want to use for pi. Can someone raise your hand and tell me, based on the blue circle that we see here, what would you choose? Based on the criteria, what would you choose? Anybody? Got a couple hands? 2, 3. Come on, guys. Who knows? Which one would you choose, the decimal or the fraction? Janet? Why?
Because it's a multiple of 7.
Yes, because 7 is a multiple of 7. You say, well, but I have to square it. Well, if you square a multiple of 7, it will still be a multiple of 7. Okay? So does everybody see that 7 would be a multiple of 7? That's why I want to use the fraction 22 over 7 times 7 squared. Now, this is important. This is not where I do the cross reducing. I must follow order of operations. I need to square 7 first. What is 7 squared? 49. Okay, don't forget 7 squared is the same thing as 7 times 7, not 7 times 2. So 7 times 7 is 49. 22 over 7 times 49 over 1. Wait a second, I thought it was 49. Why would I write 49 over 1? To make it a fraction, so it's visually a lot easier to see what cross reduces. All right, you guys think you can finish that up now? All right, so I'm going to cross reduce. 22 times 7 is, anybody get it? 154 centimeters squared. Now, let's talk about, and I know that this seems kind of insignificant, okay? Let's talk about this equal sign here for a second. Does everybody agree when you multiplied 22 times 7, it was 154, right? But that actually is not the exact specific answer. Yeah, sure, I multiplied and I got 154. But why would this actually be approximated?
Because the pi is continuous. That's only
Exactly. Is 3.14 or 22 over 7, is that the exact value for pi? All right, so if I could rewind to the beginning of 9.1, we should have started off chapter 9 talking about this. Anytime, okay, listen to this, guys. I know it doesn't seem like a major thing, and theoretically, in the grand scheme, we're calculating things correctly, but we do need to understand that this is not the exact answer because I actually used a rounded value for pi. So just in case, just as a refresher, we know that 3.14 is the rounded value for pi, okay? So everybody with me? 3.14 is not the value for pi. If you were to Google it, it's like 3.14 and it goes on for like 52 decimal places, okay? It is. It is. And it's not repeating. It is the most famous irrational number in mathematics is pi, okay? So because 3.14 is already rounded, every problem that I solve that has pi is actually rounded. Even when you multiply and your answer is a whole number like 154. Does everybody understand what I'm saying? I'll keep kind of re-emphasizing that, but we're going to try to get in the habit every time we use pi, we're going to start approximating our answers, okay? Because we're acknowledging this is not the exact value for pi, all right? Okay, let's do 26. 26 inch, wait a second, 26 inch what? What value is that on the green? That is the diameter. The formula for area calls for the radius. So the mistake that we see here, you probably can see what mistake could be made here. You plug in 26 for R, but 26 is not the radius. Okay, go ahead and make your substitutions and go ahead and solve this. Okay, so A equals 3.14. I use that because 26 is not divisible by 7. 3.14 times 13 squared. Where did I get 13 from? Yes, half of the diameter. All right, what's 13 squared? 169 times 3.14, 530.66 inches squared. Why did we approximate?
Because it's not, because pi's rounded.
Yeah, pi's rounded, but also when I multiplied that, was 6 repeating or no?
No.
6 was not repeating? Okay. All right, so 530. Yep, inches squared. All right, let's see, semicircle. All right, so just like yesterday with perimeter, I found the circumference and divided by 2 because it was half of a circle. That's exactly what I'm going to do today. I'm going to find the area, okay, and then as if it was a whole circle, and then I will divide the area by 2. All right, now there's nothing else to add because I'm not finding the perimeter. I don't have to worry about that. All I'm looking for is the space in between, the area. All right, so here we go. A equals pi r squared. I'm going to act as if this is an entire circle. All right, what if this was the whole circle that I'm finding? That's what I'm doing here. Okay, pi r squared. Which value would I want to use for pi? 3.14, right? 3.14 for pi. Because, again, 30 is not divisible. But do I plug in 30 for the radius?
No.
What do you think? 15. I must half the diameter. Okay, and plug in 15. Okay. 15 squared. 15 squared is 225 times 3.14 is 706.5. If this had been a whole circle, this would be the area of the circle. But I need a semicircle. So what do I need to do to this value? Someone raise your hand. What do I need to do to this value, Isla? I need to half it. Okay? So I find the area just like I did in the last example, but now I'm going to divide it by 2 to find the area of the semicircle, 353.25. And again, I estimated it because my problem involved pi. And pi is not exact. Okay. All right. Last example, a tsunami warning siren. So, did you know that in the areas that are at a tsunami risk, that they actually have sirens that can alert the people in the area, right? Actually, even in the U.S., what kind of sirens do we have in the U.S., like in the yes, in the Midwest, okay? In the Midwest, we have tornado sirens. I don't know if you remember, it was a couple years ago now, but in Hawaii, they also have like sirens for like bomb threats and things like that. Actually, it went off a couple years ago. So it was a false alarm. So let's read now that we're all kind of caught up on what's the topic here. Because remember, modeling real life, it always has some kind of a topic. I want you to try to connect to that topic. It really does help when you're trying to kind of visualize what's going on. Tsunami warning siren. So, it's on one of those like telephone poles, and it blasts a siren. It can be heard up to 2.5 miles away in all directions. From how many square miles can the siren be heard? The first thing I need to decide is 2.5 miles, is that a radius value or a diameter value? It's a radius, because from the siren, which is my point of center, it extends out 2.5 miles in all directions. So that would be a radius value. Okay? So how much space does that fill all the way around 2.5 miles in all directions? That would be an area problem. Do you see that? Okay. So A equals pi r squared. And I'm using this formula to figure out why do you think this would be beneficial? Say that you're the mayor or the governor, on this tiny island. Why would this information be helpful? You're the one responsible for placing the sirens around the island.
So people won't die.
Well, obviously. But you're the one who's putting the sirens out. Wouldn't you want to know how far out the sound extends so you don't put the sirens too close together or too far apart from each other? All right? So this can definitely be helpful if you're the person in charge and that ends up being your job one day. All right? So A equals pi r squared. A equals 3.14 times the radius, which is 2.5, squared. Now, you need to be careful. You don't multiply first. You must square the radius. 2.5 squared is 6.25. So 3.14 times 6.25 gives me the approximate coverage. It's about 19.625 miles squared. All right, now your book rounds this up to 20. Okay? Now, while it does follow the rounding rules, and it kind of goes back to what we were just talking about, why would I not want to round this up? Why would I rather round this down?
So you can be exact.
Not exact. Maddie?
Because, if you rounded it to 20 people at the 20 mile mark,
Right. Like the people in that little tiny distance, this is square miles we're talking about, there might be some people who are actually outside the range. So if I'm the person, I would rather have an overlap and round down to 19 than round up to 20 and say, oh, well, within 20 square miles. No, I mean, if this is accurate, within 19.625 miles. Okay, so that's why I would actually, again, when it's modeling real life, we've got to think what would be the best decision, not necessarily following the rules of rounding, right? When lives are at stake, okay? All right, so, we're just kind of trying to tie in where this would apply, and I think it's a pretty good example, although hopefully we never have to face a tsunami. All right?
Florida ever have to?
Not a tsunami, but storm surge, which is sort of the same thing. It's a flooding of waters coming in on the coast. Tsunamis are a little faster, and they're caused by earthquakes, not hurricanes. All right, that's everything you need to know for 9.2.